Agaz, but before we start, let's do this particular thing. What? I want to know you guys are ready for learning or not. If you guys are ready for learning, then let me know. Just type down in the comment box you are ready, and then we will go further with the today's discussion. So if you are ready, very good evening to everybody. Very good evening. I know you are very happy to learn. I am very happy to teach you. That's why I call it as what? Happy learning. So let's make our learning happy and more detailed, more and more easy. For that I need your readiness. If you are ready, type down in the comment box ready, and let's start. Let's begin the session. चलिए, तो आज का पहला जो टॉपिक है फाइंडिंग मिनिमम. कैसे फाइंड करेंगे? आप बोलोगे सर मिनिमम ये रहा सर, एक ये रहा मिनिमम. अरे this way you can find the minimum just because you guys can see all these elements together. But if you have an array, how algorithmically you means not you exactly, your computer will find the minimum. कैसे मिलेगा रे बाबा? How your computer will find the minimum? ओहो, मेरा ये माउस क्यों नहीं चल रहा है? Wait a minute. Till then you can give me the approach. Till then you can give me the approach how exactly you can get the minimum. कैसे minimum मिलेगा बताएं जरा. How to get the minimum? How to get the minimum? Okay, so to find the minimum, I will bring you back to your summer days of your childhood. Let's say in the summer you are at your nani's place. Nani means your grandmother's place. Now in that one single what should I say, a particular gallery or a particular hall or a particular place where all the kids are playing, and your father comes, or maybe your mama comes, or uncle comes from the market or from the farm and bringing lots of mangoes for you, right? And the mangoes are there. Now you will go towards the mangoes and you will fetch it. कूद पड़ोगे मैंगोज के लिए. Now the thing is, from the kitchen your mom is saying and shouting only one at a time. In that particular case, what you will do, you will try to get the best mango, biggest mango possible, right? So what you will do, you will get whatever in the first glance, you will get the first mango, the biggest mango, you will grab it. You will keep it like this way. And now what? Now you are searching. और कोई तो नहीं है. Is there anything which is better than this? No, not good. Okay, this is good. Okay, if this is good, I will grab that and I will throw it. No, this one is good. Right? Exactly the same thing you are going to do in finding minimum. In the first glance, whatever the element we are getting, just pick that element as the minimum one. Pick minimum is equal to 15. Fine. Now what? You will have to compare this 15 with 8. 8 is lesser than 15. Yes. Then 8 can be minimum. Then compare 9 with current minimum. 9 is lesser than 8? No. 7. Compare 7 with 8. 7 is lesser than 8? Yes. So you will have to replace. Oops. Some problem is there. Okay, let me make it like that way. So 7 is lesser than 8. Yes, 7 is lesser than 8. So what we will do? We will update this minimum by 7. 12 is lesser than 7. No. 19 is lesser than 7. No. 20 is lesser than 7. No. 4 is lesser than 7. Yes, 4 is minimum now. Till now 4 is minimum. Now next element we will compare with minimum. 21 is lesser than this. No. 2 is lesser than this. Yes, 2 is minimum. 11 is lesser. No. 6 is lesser. No. 1 is lesser. Yes, update. 1 is lesser. Fine. 5 is lesser than 1. No. So that's how you can find what? Minimum. Now listen. Total, how many comparisons you made here? How many number of comparisons you made here? Number of comparisons. is equal to n minus 1. If you have n number of elements in the array, how this element you copy directly as minimum? Yes. There is any comparison of this element with any minimum? No. There is no any previous minimum. After that, from here to here, all these elements will be compared with your current minimum. So that's why number of comparisons will be n minus 1. अब बात करते हैं एल्गोरिदम की. हाउ टू राइट द एल्गोरिदम? सो फर्स्ट ऑफ ऑल वी विल टेक one particular variable minimum. This minimum I will initialize with first element of array. You will say a of 0. ना बाबा, डेटा स्ट्रक्चर है ये, a of lower bound. Now I'll have to write the loop from where to where after lower bound this index element. So I is equal to k plus 1 to I less than equal to upper bound I plus plus. In the loop, what exactly I'm gonna do is compare. Can you tell me what is the comparison statement? Can you type down in the comment box what should be the comparison statement? If the element at index I is lesser than my min index or my min element, if yes, then update min by a of I. Otherwise don't. Just go for the next iteration. Once this particular loop is done, I will return what? I will return min. Don't worry, I am not asking to return your friend's money. You can keep it. खा जाओ अपने दोस्तों के पैसे, उसको रिटर्न करने के लिए नहीं बोल रहा हूँ. Right? Okay. So if this is the loop, number of comparisons always n minus 1. Can somebody tell me what is the time complexity of this algorithm? What is the time complexity of this algorithm? जल्दी बताने का, टाइम नहीं लगाने का रे बाबा, जल्दी बताने का. कितना टाइम लगेगा इस एल्गोरिथम को रन करने को? उप्स, ये k क्या है? अरे बाबा k नहीं, LB प्लस 1 लिखना चाहिए मुझे यहाँ पे. जी हाँ, गलती हो गई छोटी सी, माफ कर दो सरकार, हमने आपको पढ़ाया है. HLB, okay. Yeah, I did it. Now listen. If I want to calculate the complexity, first of all, I can understand that this particular loop will run n times. Okay, fine, I got it. But can I stop my searching of minimum, finding minimum in middle also? Suppose I am saying I will compare up to this element and I can assure that after this you will not have to compare and I can get minimum. No, I'll have to go till the last. Yes. I'll have to run this loop always n times. Yes. In that particular case, the runtime complexity will be theta of n. Theta of n. So runtime complexity जो होगी इसकी, that runtime, the time complexity of the algorithm will be equal to theta of n. Why? Just because every time when we find out the minimum, I'll have to run this particular loop always n times. Now, can I ask another question? What is the space complexity of this algorithm? What is the space complexity of this algorithm? What is the space complexity? Space complexity पहले ये तो बताओ होता क्या है? What is space complexity? Space complexity means space required by this algorithm. Okay, in this algorithm, extra how many spaces I required? One min variable, one I variable. That's it. Anything extra? No. Only two variables? Yes. For any value of n? Yes. So what should I write? What should I write? Constant time complexity. or sorry, constants space complexity. So what should I write here? Either I can write theta of 1 or I can write big O of 1. Space complexity. Now if you don't understand what is the difference between theta and big O, once again I would like to explain you. If you would have written the big O of n, the big O of n says that you might require n comparisons, or you might require this loop to run for n times, or you might require the number of operations in n, but it is possible to get the answer of the same algorithm in less than n times also. That is big O of n concept. So when you say theta of n, means you are going towards more average, more exact bound. Like every time if you run the loop always n times, yes, then you can write theta of n. If you say no sir, maximum we will run the loop n times, sometimes lesser than that also possible, then we will go for big O of n. You have already, I have already explained that. Fine, chali. Now let's call another method. Let's check out another method to find out minimum. So we have seen one minimum method, how to find minimum. Already one method we have seen. Now let's see another method. This particular method is called as tournament method. ये तो बड़ी फैसिनेटिंग सी लग रही है. अरे सर, टूर्नामेंट तो हमें बहुत पसंद है, राइट? चलिए, तो फर्स्ट ऑफ ऑल, बिफोर आई एक्सप्लेन यू टूर्नामेंट मेथड, आई विल हैव टू एक्सप्लेन यू द टूर्नामेंट का रूल. So let's say in your college, in your office, in your colony or building or society, there is a tournament of badminton. Okay, now one player game it is, means two player game, one here, one singles game you are having. Fine. And now based on previous skills and previous years results, you have given each and every player, each and every participants a rank. Every participant is having a rank. Now you have given some random draw, random league matches for each and every player, and the rule is simple: the better ranking player wins always. The better ranking player wins always. So let's say first match happens with the player ranking 15 and with the player ranking 8. Now you tell me which fellow will win. The fellow which is having rank 8. Why? Just because it is better. That fellow is better. Understanding? This is the tournament rule. And it is a knockout tournament. Knockout tournament means if a person loses the game, that fellow is out of the tournament. If fellow is winning the game, going to the next round. Very simple. Now listen, exactly same method I am going to apply to find the minimum. I will play a game between these two. Ranking 8, ranking 15, ranking 8 player goes to the next round. So what I am doing is I am comparing two members, two elements, first two elements of array 15 and 8, whichever is minimum going to the next round. Now comparing these two elements 7 and 9, whichever is minimum will go to the next round, 7. Now compare 12 and 19, minimum is 12, go to the next round. Compare 20 and 4, minimum is 4, going to the next round. Now you need to do the same thing till you find the winner of the game. Compare now two elements 8 and 7. Next element here, the winner is what? Winner is 7, minimum element. From here compare 12 and 4, minimum is 4, winner is 4. Now ultimately you compare 7 and 4, winner is 4. From here also you got the same minimum element. Yes. From regular method also you will find minimum 4 only. Yes. But how many comparisons here now? अभी यहां कितने कंपैरिजन लगेगा? अरे ओ सांभा, कितना कंपैरिजन हुआ रे? So tell me how many number of comparisons here? Answer will be exactly same as the previous one. Number of comparisons will be equal to same for n numbers, n minus 1. I knew 100% that somebody will always ask a question, sir, number odd हुए तो? It can be possible that at any level, if you have odd numbers, then the last element will not be compared with anybody. Look at this. I'm telling you, look at this. I'm telling you, look at this. First of all, let me complete this. How many number of elements? 1, 2, 3, 4, 5, 6, 7, 8. 7 comparisons you made. 1, 2, 3, 4, 5, 6, 7. 7 comparisons you made. Yes, n minus 1. Fine. Look at this. I am taking 5 elements. Let's say 15, 8, 9, 7 and 12. Let's do the same method. Compare 8 and 15, 8 goes to the next round. Compare 7 and 9, 7 goes to the next round. There is no any player against 12. If there is no any player against somebody, that fellow will go to the next round without playing. आपको पता है ना, बाइट मिल जाता है. Walkover, we call it as walkover in games, right? So that fellow 12 will get a walkover and will go to the next round directly without any comparison. Fine, no problem. 8 and 7 you will compare from here. 7 go to the next round. 12 still not having any element to be compared. Yes, no problem. 12 will go to the next round. Ultimately in the final, 12 will play compared, 7 will win. 7 is minimum. 5 elements we had. Let us see how many comparisons. 1, 2, 3, 4 number of comparisons. Still same to same comparisons, n minus 1. N minus 1 comparisons. So at any level, if you have odd number of elements, then the last element will be going to the next round without any comparison. But still for n number of elements, n minus 1 comparisons will be there. I hope you guys understood this. Now listen, if this much is clear, then there is a difference. There is a difference from this method to this method, and the difference is the space complexity. The space complexity here will be more. Kaise? Look at this. What I told, you will compare these two, and comparison winner of these two will go to the next round, 8. Then comparison winner 7, comparison winner 12, comparison winner 4. Where will you store all these 4 winners? कहाँ रखेगा ये 4 विनर को? Where you will store these 4 winners? These 4 winners to store in an array. Of course, you'll have to store these 4 winners in an array, and for that you will need extra space apart from given array. Right or wrong? Yes. अब आप बोलोगे सर array के starting part में store कर दें तो? In this array only starting half part, if we will store this, then these 4 elements will be lost and we will be having these elements, which is not good. We can't destroy our current given array. No. So we will have to keep these winners in the other list, and for that space complexity of this algorithm will be how much? Space complexity of this particular algorithm will go towards n. We will require n space, n by 2 almost, n by 2 asymptotically n. Got it? Understood? Understood? So 2 methods we have seen. The regular one, which is finding minimum by just comparing first element taken as minimum and then comparing minimum with other elements. If other element, any element comes as lesser than minimum, we will update that as minimum and go on. In that case, number of comparisons same to same, n minus 1. Based on that, time complexity theta of n, space complexity constant. Here, number of comparisons n minus 1 in the tournament method. Because of that, of course, time complexity will be theta of n. Yes, my dear friend, time complexity here will be theta of n. And space complexity is theta of n. Now you tell me which one is better. कौन सा method better है? This one or this one? See, time complexity is same to same, but of course, if some method can save us more time, or sorry, more space, of course that is better. So this is better. इसीलिए आपको कॉलेज में यही सिखाई जाती है, ये सिखाई भी नहीं गई होगी. Right? चलिए, okay, let's go next. Now we need to find maximum. I am not going to explain you how to do that. Why? Just because exactly two methods which we have seen, both methods you can apply here to find maximum also. Just the difference is comparison. The comparison here, we were finding lesser element than the current minimum. Here we will find maximum greater element. That's it. So first method says take first element as max and then compare this. This is greater than 15, no. This is greater than 15, no. So we will take max as 15. 8 is greater than 15, no. No, no, no. 19 is greater than 15, yes. 20 is greater than 19, yes. 4 is greater than 20, no. 21 is greater than 20, yes. 2, no, 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 no. 21 is greater. Akshay, number of comparison is not time complexity, but yes, it will affect the time complexity, of course. So this is the regular method. Yes, in the regular method, dear, number of comparison same to same n minus 1, time complexity same to same theta of n, and space complexity constant. So time complexity will be theta of n, right? Number of comparisons, how many? N minus 1, same to same as the previous case, only the comparison will change, that's it. And last thing, space complexity is how much? Theta of 1, constant. If you will find maximum with tournament method, can you do that? Yes, we can do that. How? Just in tournament method, when you are forwarding minimum, in that case you will have to forward maximum. Yahan se winner 15, winner 9, winner 19, winner 20, then compare, compare, compare and go to the last one. Can you do it? Yes. Can you learn it by yourself? Arey, I have already taught you. You need to just apply the opposite comparison, that's it. So can we find out maximum using tournament method also? No. If you are going using tournament method, you tell me now every single thing. I am just asking you, can you tell me how many number of comparisons for finding maximum using tournament method? How many comparisons? And what will be the time complexity? And what will be the what will be the space complexity? जाग रहे हो के सो गए बबुआ? जागत हो तो लिखते रहो। अब तो ठंड भी चली गई यार, अब हाथ रजाई से निकाल के और आराम से टाइप वाइप कर सकते हो। पहले तो ठंड हुआ करती थी, अब तो ठंड भी नहीं है उतनी कि हम हाँ नहीं सर हम तो ऐसे ही बैठेंगे, राइट? फाइन, ओके। नाउ नंबर ऑफ कंपैरिजंस विल बी सेम n-1 and time complexity will be, time complexity is theta of n. And what is the space complexity? Here space will require more theta of n, that's it. Okay, now if you want the algorithm for finding maximum, then that you will have to find out by yourself. Do it. Try to write the algorithm or a program by yourself, and that is how you will learn for your placement. So I'm giving you a small task. I have given you the method how to do that. Of course method is clear to you, I guess so. Method तो सब लोगों को clear हो चुकी होगी. आप लोगों को just एक algorithm लिखनी है इस चीज की. Can you write it? Of course you can write it if you will try to understand what is the method, and if you understood what is the method, you will be able to apply the method properly in this. Try to do that, of course you will be able to. ठीक है? Now we are going for next step. Now a given array we have. From that given array, you need to find out both minimum also and maximum also of the same array. See, this is important. You know why? Last year also चीख चीख के मैंने बताया था कि यहां से क्वेश्चन बन सकता है. Last year when I was teaching my students, I shouted like anything that there will be a question from this particular topic that can be, and there was a question from this topic, 2 mark question. I don't know 2 mark or 1 mark, but yes, there was a question and it was very easy. पढ़ते ही आंसर आए. You don't have to even touch the pen. You just read the question, check out the options and get the answer corrected. That kind of question was asked. That much easy question was asked this year from this topic. So concentrate. Concentrate. Now listen, finding minimum. Oh, not working again. Finding minimum and maximum both. So first of all, let's try to understand the regular method. The regular method says that first find minimum. First find the minimum separately, and for that can you tell me how many number of comparisons are required? How many comparisons are required for only finding minimum? N minus 1. Then find maximum separately. जी हाँ, separately later on. In that case, how many comparisons? N minus 1. Total number of comparisons? 2n minus 2. That is the maximum. Yes, maximum. Can we reduce it? Can we reduce it? Can we reduce it? Yes, we can reduce it. How? We will go with the another method that gives us the answer with minimum number of comparisons. Right? Now that particular method works. How? I'm going to explain you. And this method is very easy to understand. Once you understand, you will not forget. That's my surety. Once you understand, you will not forget this particular method. That is my surety. Let's say n number of elements are like this: a1, a2, a3, a4, a5, a6, like this way, an minus 1 and an. Total n number of elements are there, 1 to n. Fine. What I will do, I will compare first two elements. Let's assume that all the elements are unique. All the elements are distinct and unique. Then I will compare only first two elements. One comparison, and I can find that among A1 and A2, which one is greater and which one is lesser. Can I do that? Can I find out that among A1 and A2, which one is minimum and which one is maximum? Yes. Among these two, which one is larger, which one is smaller, we can easily understand. Yes. What I will do, after one comparison of these two, whichever is smaller, I will keep that in a separate array. In a separate array, whichever is smaller. So I will keep that smaller elements in a separate array of these two, and greater element in a separate array. So I will compare two elements. छोटा यहाँ, बड़ा यहाँ. Whichever is smaller, keep here. Whichever is greater, keep here. Now we will compare next two elements. Same to same I will do. One comparison. After one comparison, one smaller element here, greater element here among those two. Then I will compare next two. One here, one here. Similarly, I will compare till the last. One here, one here. Understanding? Okay, let me take a very simple example. Suppose we have 5, 3, 1, 6, 9, 4. These are the elements. I will compare 5 and 3. 3 in the smaller element list, 5 in the greater element list. Compare these two. One is smaller, one here, 6 here in the greater one. 4 here, smaller element, 9 here, greater element. Got it? Very simple. Very simple. right. So I'll have to declare two separate arrays, one for smaller elements storage, one for greater element storage. Example समझ में आया? Now listen, I'm removing this example. I'm removing this example. No? Okay, fine. I'll keep it. No problem. Now I am having a claim. That claim you will have to understand. I can claim that the maximum of my entire array cannot be present here. Why claim? See, I compared 2 elements and I have copied smaller of each comparison here. So if I say this is maximum, this cannot be maximum. Why? Just because this particular element came here in this list because it was lesser than some element in the comparison. This is also not the largest of entire list. Why? Just because यहाँ इसीलिए आया है, this element has come in this smaller list because it was lesser than some element present in greater. Then here, here, this particular entire smaller list will not contain the largest element of your array. The largest element will be present here in greater list. Similarly, the opposite one. The smallest element of your entire array cannot be present here. Sorry, cannot be present here. It will be here only. Right? Now, what my problem is, my problem now has reduced. I'll have to find minimum from this. And I'll have to find maximum of this. Right? If I find minimum of this will give you or will give me minimum of entire array, and maximum of this half greater elements ka list will give me maximum of entire array. Minimum will be taken from the smaller list element ka list, and greater maximum of entire array will be taken from this. Let's talk about comparisons now. First of all, you had n elements, right? Now you compared one comparison for 2 elements, another comparison for 2 elements, another comparison for 2 elements, another comparison for 2 elements. Total if n elements, can I say total how many comparisons required initially to make these two lists? कितना comparison लगा ये दो list बनाने में? How many comparisons to make these two lists? Tell me, how many comparisons? Initially n by 2 comparisons to make these two lists, right? So initially to make two lists, first one to make two lists, number of comparisons are n by 2. Let me write it like this way. ज़्यादा अच्छा लगेगा, n बटा 2 in Hindi. Second, now already we have this smaller element ka list and greater element list. Half elements of all n elements will go here and half will go here. Can I say total n by 2 elements will be here and n by 2 elements will be here of entire n elements? Yes. Now my problem is I'll have to find minimum of n by 2 and maximum of n by 2. If I'll have to find minimum of n by 2, to find minimum of n by 2, I will require n by 2 minus 1 comparisons, and to find maximum of largest elements ka list, I will require n by 2 minus 1 comparisons. Comparisons total will be how many? Total comparisons will be 3 times n by 2 minus 2. And of course it is lesser than 2n minus 2. Of course it is lesser than 2n minus 2. चेक आउट, एक बार वापस से चेक करते हैं. वंस अगेन लेट्स चेक इट आउट. Finding minimum and maximum both. First of all, we had n number of elements. What we did, we compared 2 elements. We compared 2 elements. Smaller element will go in this list. Greater element of comparison will go in this list. Total n by 2 comparisons we made. Yes, fine. And we had two lists of n by 2 elements. And after that, we claimed that our minimum of entire array will be in this list, maximum will be in this list. Let's compare. Let's find minimum with whatever method you want, tournament or regular, whatever. Just find out minimum of this list. I will get minimum in n by 2 minus 1 comparisons. I will find maximum with n by 2 minus 1 comparisons. Total how many? N by 2 plus n by 2 minus 1 plus n by 2 minus 1, total 3n by 2 minus 2 comparisons. Of course, फायदा हुआ if n is equal to 1 lakh. If n is a very big number, then of course we will be having good comparison difference. Now look at this. If somebody asks number of comparisons here these many, fine. What is the time complexity? If you ask the time complexity in the asymptotic rate of growth notation, time complexity is still theta of n only. Time complexity same to same, but just comparison got different. Pranav is asking, sir, I have scored around 50 this year, but I want to give GATE again next year with job. Can you suggest when should I start? Pranav, start now. And I am telling you one thing, if you are really looking for your mark booster or your mark boosting, then you should go with the really better preparation than the last year. Just because you know lots of things, that's why you are scoring 50 marks. But I would suggest you should go with detailed content, with more organized content, so that you will put less efforts with your job and you can get a good outcome of it. I would recommend, please go for an Academy Plus if possible. What is the problem with voice? Still there? I don't know. Check out, still there? Still there? Chal. Okay, fine. Okay. Now time complexity is same to same, just the number of comparisons will be different. If you will say, sir, what happens if the number of elements will be odd? किसी ने पूछा नहीं, किसी ने पूछा नहीं, किसी ने पूछा नहीं. Nobody asked, sir, what if the number of elements will be odd? If we have odd number of elements, what we will do? Compare two elements, find, compare two elements, find 2 2 2 2. We will have only one element remaining. Now what to do with this one element? छोड़ दे, फेंक दे, बाहर निकाल दे? नहीं, ना, ना रे बाबा, ना. What we will do with that element? We will keep that element in smaller and greater list both, without any comparison. Just keep that element in this list also, in this list also. So in that case, what happens if we have odd value of n, in that case number of comparisons is equal to 3 of n by 2 का seal value minus 2. only one change will be there. See, look at this. Here n is even, that's why it is divisible by 2, integer value into 3, integer minus 2, integer comparisons. But here n by 2 will not be an integer value, number of comparisons cannot be, of course, in float. That's why we will take seal value. Why? Just because one half extra comparison will be required, that's it. Half comparison will be required, that's it. Extra half comparison. Fine. Okay, now listen. If you understood this year what was the question in GATE? The question in GATE was the minimum and maximum number of comparisons to calculate minimum and maximum both. The comparison can be between what to get the minimum and maximum both of a given array. So minimum number of comparisons are how many? 3n by 2 minus 2 seal value. Maximum comparisons how many? 2n minus 2. So your comparisons will be between maximum 2n minus 2 to minimum this much. And that was the option, correct? You don't have to even write anything, re baba. Yaad rakho. If you can remember the formula, you can get the answer correctly. What do you say? Is that fine? Is that fine? Yes or no? Till now, everything is clear, cool, understandable. Maza aa raha hai? Are you enjoying? Are you guys enjoying? Yes or no? Can you please tell me? Now the next thing is finding second minimum of the given array. First minimum how to find? That's very simple. But how to find second minimum? That is another challenge. Okay, so how to find second minimum? Very simple. Regular method. Method number 1. We say first of all find minimum, right? And that will take how many comparisons? If n number of elements are there, then number of comparisons will be n minus 1. After that, find minimum of remaining elements. So you keep minimum aside and then n minus 1 elements are there, find minimum of those remaining elements. If you will find minimum of those remaining elements, that will take n minus 2 comparisons. Total how many comparisons? 2n minus 3 comparisons. Of course, that is not our intended answer. That is not our intended answer. इतना तो हम इतने में संतुष्ट होने वालों में से नहीं है. तो हमें क्या चाहिए? और कम करना है कंपैरिजन. यस, हाउ टू डू दैट? कैसे करेंगे? कैसे करेंगे रे बाबा? With minimum comparisons. For that, we need to understand here tournament method. We need to understand here tournament method. Look at this. Look at this. Look at this. I am telling you how to do that. I'm telling you, I'm going to tell you exactly how to do that. This, I am expecting that from here they may ask a question maybe next year. I am expecting since a few years that they will touch this particular topic definitely in the GATE. Just because they have come to this particular point, of course they will come next to this also next time. No, we don't have to sort it. Sorting may number of comparisons will be so many, even though in terms of n log n we can't do that, we can't afford that, and 2n minus 3 is the maximum comparison anyway we are getting. After 2 comparisons total, we will not afford that much. So what we will do is, let me explain you. Just sit back, relax and enjoy the learning whatever I'm going to provide you. Listen what exactly the method is, how exactly the method works. So let's take the tournament method. 5 9 4 2 6 1 3 7. compare these two elements. Minimum is 5, goes to the next round. Compare these two elements. Minimum is 2, goes to the next round. Minimum is 1, goes to the next round. Minimum is 3, goes to the next round. Fine. Now minimum is 2, compare these two. Minimum is 1. Finally compare 1 and 2. Minimum is 1. Fine. So where I can find second minimum? If you say the person against whom the best winner, the winner is compared at the end, that is the second minimum. Abhi possible hai. It is possible now in this example that second minimum is playing final against my best player. If you remember that tournament method, what I told, these two are the players with ranking 5 and 9, players with ranking 4 and 2, players with ranking 6 and 1, players with ranking 3 and 7, and better ranking player wins and goes to the next round. Who wins? The best player with the best ranking wins. But all the players are going out? Yes. So who will be the second best player then? The player with the second best ranking. How can I find that fellow? And to find that particular fellow, if your answer is let's check out that my winner plays final against whom, that is the second minimum. No, I may have the array like this, na babu. Let's say I'm having array like this. Now what happens? 4 and 3 winner is 3, 2 and 7 winner is 2, 1 and 2 winner is 1, 1 and 3 winner is 3, winner is 1. So the second best player comes to the final always? No. But I can assure that second best player can go out of the tournament only when if that fellow is playing against my best player. सेकेंड बेस्ट प्लेयर या सेकेंड मिनिमम कंपैरिजन की लिस्ट से तभी बाहर हो सकता है जब वो कंपेयर होगा हमारे मिनिमम एलिमेंट से. Are you agree on this point? So what exactly I'm going to do is I will first check out the minimum. I will find out minimum with tournament method. Okay, so using tournament method, I have calculated minimum. Yes. After that, what I will do is I will get the list of those elements against whom I have compared one from the first to last. I have compared one with 6 initially. Yes. I have compared one with 2 here. On this level, I have compared one with 3. I have taken the list of those elements which I compared with one from first to last. This is the list. Find the minimum of this. Find the minimum of this, which is 2, and that is my second minimum, boss. एक ऐसा प्लेयर जो कि बेस्ट है उन प्लेयर्स में से जिन्होंने वन के अगेंस्ट मैच खेला था. The player is the second best player who is actually the best among those members who played against one and lost the match, gone out of the tournament. Right? Now, if you are finding minimum using tournament method, of course, you all know that the number of comparisons are n-1. Number of comparisons, how many? n-1. Everybody knows that. अभी थोड़ी देर पहले ही बताया मैं. Everybody. Now, if you are finding this particular list, this list of all those elements which I compared with one will have log of n elements. Log of n elements, this particular list will possess. And to find minimum of log n elements will be how many comparisons? To find minimum of these log n elements, how many comparisons? Find minimum of compared elements with min, and that will take log of n minus 1 comparisons. आई होप मैंने अपने सिर पे ही ना लिख दिया हो. Now, total number of comparisons will be how many? Total comparisons will be equal to n plus log of n minus 2. राहुल राज सेज मजा आ रहा है. तो राहुल प्लीज एक छोटा सा काम और करिएगा. आप अपने जितने भी जूनियर सीनियर या जितने भी लोग आपके साथी हैं जो डेटा स्ट्रक्चर सीखना चाहते हैं, वो चाहे प्लेसमेंट के लिए हो या फिर गेट के लिए हो, उन्हें ज़रूर यहाँ लेके आएँ. और दूसरे सब्जेक्ट सीखने भी अगर कोई भी चाहता है तो उनसे ये पर्टिकुलर प्लेलिस्ट और ये चैनल के बारे में ज़रूर शेयर करें. लॉग इन कैसे आया? डेफिनेटली मुझे उम्मीद थी कि ये क्वेश्चन आएगा ही आएगा. देखिए व्हाट आई डिड, I compared one element among total n elements. I have compared one element from this particular level 6 with 1. After that I made the list half. Then from this level I have taken only one element 2. Then after that I made the list half. Then from this level I have taken only one element with which I compared 1 3. Then I have made the list half. If you remember my first lecture, I told you if you perform one operation per level per iteration and after that you divide n by 2 n by 2 n by 2 n by 2 till 1, then you will have log n number, log n complexity, right? So that's why the number of elements in this list will be log n. Full DS concept for GATE will be taught in this series. Yes, Tapas, 100% sure. That is my guarantee. I will teach every single concept of data structure in this particular series. Yes, I will do it. Saturday, Sunday, yes, Rahul. Usually Monday to Friday we teach, and Saturday, Sunday, if will be required, we will have some DPP or some other marathon sessions. Okay, fine, sure. Okay, great. Understood this much? If you understood this much, then remember, if you find out second minimum, you can find second minimum with minimum comparisons equal to n plus log n minus 2. This log n base क्या रहेगा इसका? The base is 2. Why? Just because here we are dividing the list by n by 2, n by 2, n by 2. There is one thing here. There is one thing here. There is one thing here which you need to understand in this method. Extra space required, which I already told you. Extra space required, which I already told you. Yes, my dear friend, in the tournament method we require extra space. So space complexity of this algorithm will be how much? Space complexity of this algorithm will be equal to theta of n. Extra n space will be required to store these lists. Apart from that, in this one, if comparison is 2n minus 3, can you tell me any extra space required here? Yes, only min variable, max variable and some loop variable. So space complexity of this algorithm, regular one, is how much? Constant. And let's go back for this one. What is the space complexity required? Can somebody tell me? Can someone tell me what is the space complexity required here? The space complexity required here is n. Why? N by 2. Where you will store these elements? In a list, in an array. Yes, in this particular also n by 2 elements you will have to store somewhere in the array. Yes, so space complexity here will be again, I'm writing. कहाँ लिखें? यहाँ लिखेंगे space complexity will be theta of n. Extra space required, बिल्कुल theta of n. फाइन, चलिए. तो अब मैं आज से आप लोगों के लिए, इनफैक्ट अगर आप लोगों ने कल भी मेरा लेक्चर देखा हो, yesterday also I brought some quizzes. You will have to find the answer of these quizzes now. What is the answer of this question? Quickly. Tell me what is the answer of this particular quiz. I'm waiting for your answer. I'll give you 30 seconds total. Yes, my dear friend, only 30 seconds I'll be giving you. Answer is number of comparisons. To find maximum of 120 elements, we know that n minus 1 comparisons. 120 minus 1 is 119. Simplest one. Yes. Okay. Another question. Here it is. The minimum number of comparisons required to find minimum and maximum of 200 numbers is. 200 numbers we have. 200 numbers if we have, then minimum comparisons to find minimum and maximum both will be how many? How many? We all know if n value is even, 3n by 2 minus 2 comparisons. जल्दी से आंसर बताएं, जल्दी से आंसर बताएं. Answer is 3 by 2 into 200 minus 2. How much? How much? 300 minus 2, 298. यार कैलकुलेशन मिस्टेक नहीं करने का. हाँ, जल्दी में कैलकुलेशन मिस्टेक नहीं करने का. These are the practice questions which I wanted you to solve correctly. No any mistake you will have to do. No. Last question. Now you will have to solve this question by yourself. I will be waiting for your answer. What is the answer of this question? Jaldi batao re baba. If we are finding maximum and minimum both of odd numbers, n is odd, here n was even, right? We have put the direct value. If n is odd, we will put what? 3 n by 2's seal value minus 2. Total number of comparisons. Seal value, you understand what is the seal value? 83 divided by 2 will give you 41.2. 41.5. 41.5 का seal value will be 42. 42 into 3, 126 minus 2, 124. 124. Don't go with the rush. Don't rush, then only you will get correct answer, dear. Don't rush. Rush नहीं करने का है, तभी मिलेगा correct answer. Otherwise you may make small calculation mistake. Seal value means the upper integer. So 41.5 का seal value will be 42. Got it? Okay.